Good morning, and welcome to the Opoku School e-learning program. I am Richard Adomako, your elective mathematics tutor for Form 1. Let's get our pens and notebooks ready for an interesting class. Numbers, as we all know, can be written as products of their factors. For example, now 25 can be written as 25 is written as 5 multiplying 5 or 5 times 5. 81 is also written as 3 times 3 times 3 times 3. 128 is also written as 2 times 2 times 2 times 2 times 2 times 2 3 4 5 6 times 2. Now this number 1,048,576 is also written as 2 times 2 times 2 times 2 up to the 20th time. Now, to save time and space, mathematicians have developed a shorthand for writing such repeated products. So, for example, instead of writing 25 as 5 times 5, we can choose to write it simply as, now the number being multiplied or the factor is 5. So we write 5, then we count the number of times the 5 is being multiplied. So we have 5 and 5, so which is 1, 2. Then we write it as a superscript here. Now 81, instead of writing 3 times 3 times 3 times 3, we know that the common or the repeated factor here is 3. So we write the 3. Then we ask ourselves, how many times is the 3 being multiplied? So we have 1, 2, 3, 4. So we write that as a superscript. 128 is also written as 2. Then the number of times the 2 is being multiplied. 1, 2, 3, 4, 5, 6, 7. So that 1, 2 becomes a superscript. Last but not least, 1,048,576 is also written as 2. Then we count the number of times the 2 is being multiplied, which is 20. So that 1, 2 is written as a superscript over here. Now this shorthand form of writing numbers is known as indices. So this shorthand form of writing numbers is known as indices or exponents. Now, by the end of this lesson, we should be able to define or explain indices in our own words, and then give 3 examples of indices. Now, we should also be able to use the laws and properties of indices to solve questions. So let's look at the definition for indices. As stated earlier, we said that when we use a shorthand or a shortcut form of writing repeated products, then we call it indices or exponents. So we define indices or exponents as So we are saying that indices is a simple way of writing repeated products. For example, as we have stated earlier, when we have 3 times 3 times 3 times 3. Now the simple way of writing this is we write the 3, which is the number being multiplied. That is the repeated product, which I have underlined over here. Then the number of times it is being multiplied. 1, 2, 3, 4. So this shorthand notation is known as the index notation or indices or exponents. Let's look at another example. Now we have 1 over 2 times 1 over 2 times 1 over 2. The repeated product here, or the repeated factor here, is 2, 1 over 2. So we write 1 over 2. Then we ask ourselves, how many times is it being multiplied? 1, 2, 3. So that becomes a superscript. So we write it over here. Now we can also use 2, then we bring an exponent of, let's say, 5 here. Now what this means is the number 2 is being multiplied 5 times. So we can write this in expanded form as 2 times 2 times 2 times 2 times 2. So when it is written this way, we call this the expanded form. Then this is what is known as the indicial form, or the indicial notation, or the indices, or the exponents. Okay, so with this in mind, let's consider now let's consider this notation, 3 exponent 4. Now I'm using the term notation here in the sense that we are saying that the indices or the exponent is a simple way of writing repeated numbers. So it can also denote a notation. So that's why I'm using the term notation here. When we have it this way, there are 2 important questions we need to ask ourselves. So let's write the questions down. First one. Okay, so these are the 2 questions we need to ask ourselves. The first one is, which number is the repeated factor? Then the other one, how many times is the number being repeated? We have earlier stated that when we have 3, then a superscript of 4 here, this is written as 3 times 3 times 3 times 3. So straight away we can see that our repeated factor is the number 3. Now the second question, how many times is the number 3 being repeated? So we count 1, 2, 3, 4. So we can therefore state that when we write a number 3, then we bring a superscript of 4 here. This number, which is our repeated number, forms the basis of the multiplication. So we are going to call such a number the base. Now how many times is the base being repeated? So that is the 4. So we are going to call it the exponent, or the index. Now the index is the singular form for indices. So the indices is in plural, then the index is singular. Okay, so now when we write 3, then a superscript of 4, this means that we have the number 3 being multiplied 4 times. Another example, when we write, now from this we can state that the 2, which is our base, is being multiplied how many times? 5 times. So in writing this in expanded form, you can write this as 2 times 2 times 2 times 2 times 2. So this is the expanded form, and this is in the index form. Okay. Now, how do we read such an expression? We have already stated that when we write this, it means that the 3 is the base and 4 is the exponent. So how do we read this? Now, this expression is read So this expression is read 3 raised to the power of 4. 3 raised to the power of 4. Or simply, someone can also choose to read this as 3 exponent 4. Now, how do you read this? Now, A is our base, 7 is our index or our exponent. So this is read A raised to the power of 7 or A exponent 7. Now, with all these said, we can formulate some rules and properties governing indices. So let's look at the rules and laws of indices. Now let's take this note. These rules or laws are only applicable to numbers that have the same base. So let me write it over here. So now let me underline same base. We are saying that these rules or laws are only applicable to numbers with the same base. For example, when we write 3 and bring an exponent of 5 here, multiplying 3 and an exponent of, let's say, 4 here. Now they have the same base of 3. Since they have the same base of 3, it means that the following laws or the law that we are about to state are applicable to such expressions. What if we have 2 raised to the power of 5 multiplying 3 raised to the power of 5? Is the law applicable here? No, in the sense that the bases are not the same. The key word is same base. We can see that they have the same exponent, which is 5. But then we are not talking about the exponent. We are using the same base. So it means that the law is not applicable to such an expression because 2 exponent 5 and 3 exponent 5 do not have the same base. So the law is not applicable here. So let's look at the first law. So the first law is the product rule or the multiplication rule. Now let's consider this product. We are using the product A exponent 5 times A exponent 2. Okay, so let's look at how we work around this. Now the first thing we are going to do is we write this in expanded form. So writing this in expanded form, we can write this as A exponent 5. That means the A is being multiplied 5 times. So we write A times A times A times A times A. So 1, 2, 3, 4, 5. We have a product here. Now A exponent 2 is also A times A. Now our next step is taking away the brackets. So let's take away the brackets. So we write this as a times a times a times a times a. So 1, 2, 3, 4, 5 for the first bracket. Then we have a product here. Then a times a. Now we have this in expanded form. Let's write this in index form. So the repeated number is a. So we write a here. Then how many times is the a being repeated? 1, 2, 3, 4, 5, 6, 7. So it becomes the exponent. So we can therefore say that when we have a exponent 5 multiplying a exponent 2, it is the same as a exponent 7. Let's call this equation 1. Okay, now let's consider the left hand side. Now we ask ourselves which of the operations will act on 5 and 2 to give us 7. That is, when we have 5 minus 2, we get 3. 5 times 2, we get 10. But then we know that 5 plus 2 will give us 7. So this is written as a, then we write the 5, then we add 2 to it. So we get a exponent 7 as we have here. Let's call this equation 2. Now looking at the two equations, we know that when we have a exponent 5 multiplying a exponent 2, we are getting a exponent 7. But then we also state that when we have a exponent 5 plus 2, we also get a exponent 7. So in effect, we can say that from equations 1 and 2, a raised to the power of 5 multiplying a raised to the power of 2 is the same as a raised to the power of 5 plus 2, which is the same as a raised to the power of 7. So in general, when we write a raised to the power of m multiplying a raised to the power of n, we get a raised to the power of m plus n. So this is the first rule of indices. Now this can be read as when we have two numbers, or when we have numbers in indices form, they have the same base and they are being multiplied. Their indices or exponents are added. So we have these two numbers, they have the same base, they are being multiplied. So their indices or exponents are being added. So this is the product or the multiplication rule. Okay, let's look at the second rule. Or we can state some examples of the first rule. For example, one, when we have 2 raised to the power of 4 multiplying 2 raised to the power of 7, from the product rule, they have the same base, they are being multiplied. So it means that their exponent or their indices should be added. So we write 2 exponent 4 plus 7. So we write 2 exponent 11. Okay, so then let's look at another example. Now these numbers have the same base of 1 over 3. So it means that, and they are being multiplied, so we can add their exponents. So we write this as okay. So with this, let's move on to our second rule, which is the division rule. Now for our division rule or the quotient rule, we also consider the quotient. We consider a raised to the power of 5 multiplying a raised to the power of 2, or dividing rather, a raised to the power of 5 being divided by a raised to the power of 2. So now let's write this in expanded form. So we write a raised to the power of 5 dividing a raised to the power of 2. Now you know that this can be written as a raised to the power of 5 over a raised to the power of 2. Now when we write a raised to the power of 5 in expanded form, it is written as a times a times a times a times a over, now a raised to the power of 2 is also written a times a. Now we can cancel. So this a and that a cancels out. This a and that a cancels out. So now how many a's do we have? 1, 2, 3. So the common factor is a. How many times is it being multiplied? 3 times. So we can therefore state that when we have a raised to the power of 5 dividing a raised to the power of 2, we are getting a raised to the power of 3. Okay, so in general, we can state that when we have a raised to the power of m dividing a raised to the power of n, they have the same base and they are being divided. So we subtract their exponents. So we write a raised to the power of m minus n. So this is also the division rule or the quotient rule. So numbers in this form, when they are being divided, it means that their exponents should be subtracted, as we have done over here. Let's look at some examples. So examples. One. Now let's go through these examples. So the first one, we have 2 raised to the power of 7 dividing 2 raised to the power of 2. So we are saying that when numbers of the same base are being divided, their exponent or indices are subtracted. So we write this as 2 raised to the power of 7 minus 2. So this 7 minus 2. So this gives us 2 raised to the power of 5. Now let's look at the second one. 3 raised to the power of 6 dividing 3 raised to the power of 2. So we write a common base of 3. It is being divided, so we subtract the exponents. So 3 raised to the power of 6 minus 2 will give us 3 raised to the power of 4. Now let's look at this one. For the third one, they do not have the same base. So straight away we say that the law is not applicable over here. So this is the same as 5 raised to the power of 4 dividing 2 raised to the power of 3, because they do not have the same base. So it means that the law is not applicable to such expressions. Okay, now let's look at the third law. Okay, so the third law, we are going to call it the power law or the power rule, or exponents So we call it exponents of exponents. Now let's consider now we have a raised to the power of 2 all cubed. Let's not forget that when we have a raised to the power of 3, now that is written as a times a times a. So in effect, when we have a raised to the power of 2 all cubed, it is also the same as this number, which is a squared times a squared times a squared. Now let's write this in expanded form, or let's use the first rule. That's the multiplication rule. You know that these numbers, they have the same base and they are being multiplied, so it means that their indices or exponents can be added. We can write this as a, then we bring 2 plus 2 plus 2, so this will give us a exponent 6. So in effect, we can also state that when we have a exponent 2 or exponent 3, we want to find the operation which will work on 2 and 3 to give us 6. So we know that when we have a exponent 2 multiplying 3, then we get a exponent 6. So when we compare this to that, we can state that when we have a number raised to an exponent, which is also being raised to another exponent, their exponents or indices are multiplied. So in general, we can say that when we have a raised to the power of m or raised to another power of n is given by a raised to the power of m times n, as we have over here. So this is also the power rule, that is the power rule or the exponents of exponent. So a number in index form raised to another exponent is equal to the number. Then the exponent is, we are multiplying or we find the product of their exponents. So there is also the product rule. Now from this product rule, we can also state that when we have a exponent m times b exponent n all raised to an exponent of x. Now this is simplified as we are going to take the first one, a exponent m, then you multiply by this x, times, then we take the b exponent n, then you multiply by the x over here. So there is also a result from the first one that we have over here. Okay, when we have, let's say, a on b or exponent m, now that is also written as we take the first one, so we have a that exponent m over b exponent m. So there is also a part of the exponent of exponents. So with these rules or laws of indices, we can now move on to the properties of indices. So let's look at the properties of indices. Okay, so let's look at the properties of indices. The first one, we have what we call the zero index. Now for the laws, we look at where we have positive exponents. So what if we have a zero exponent? What do we do? So that is where we have the zero index. So we can write it as a raised to the power of 0. So what value would this give us? So let's try and find out. Now let's consider the quotient rule. For example, when we know that when we have a raised to the power of 4 dividing a raised to the power of 4, Now in algebra, we know that we can write this as a exponent 4 over a exponent 4. Now let's write the numerator and the denominator in expanded form. So we write this as a times a times a times a over a times a times a times a. So the a's will cancel out. Then we are left with 1. So we are saying that when we have a exponent 4 dividing a exponent 4, we are getting 1 in algebra. So let's call this equation 1. Then we can also simplify this using the second rule, which is the quotient rule. So we also know that from the quotient rule, we know that when we have a